Hello, welcome back. We are going to work on lesson 2.6 today. And so go ahead and get your book out. And we're going to start on problem number 2. I'll share my screen here. My fingers are moving. It's too dry outside. We're looking at absolute value functions. And I want to show you what they look like on Desmos, just so you can get a better picture. Oops, that's not Desmos. So if we do y equals and the absolute value of x, it's going to be a V shape. And so remember how our linear, all of our functions start at 0, 0 here. But this absolute value function goes like this. And that's because the absolute value operation, what that does is it says it doesn't matter what's inside the absolute values, it always returns a positive. So if I make a table here, you'll be able to see that if we put a -2 in for x, a +2 comes out. And if we put a +2 in, a +2 comes out. So it does whatever operations are inside that absolute function, absolute value bars, and then at the very end, it always retrieves the positive value of that. So you can shift these left and right and up and down, but this is our base graph. So let's go back to my paper here, and then let's talk about how we can solve these. So because it doesn't matter what is inside the absolute value, what comes out is a positive, that means that this x inside could be a -7 or it could be a +7, because what will come out is always going to be a +7. And so similar to solving just a regular linear equation or even a quadratic equation with an x squared, the first goal is to get this absolute value piece alone, and then we can evaluate like we did here in number 2. So we're going to subtract 3 from both sides, and we get the absolute value, the x equals a -2, and we can never get that. We just said that no matter what goes in for y, a positive comes out. So there is no real answer. No solution to that. Sometimes that happens. And actually, it'd be fun to show you that in Desmos so that you can see. So in Desmos, if I were to put in y equals the absolute value of x plus 3, okay. Okay, there we are. There's the absolute value, y equals the absolute value of x plus 3. And so if we wanted that to equal 1, that's what we said is it will never actually come out and equal 1. X can never, it can't happen. So, because if we, the output of this function can never equal 1. It can never get below 3. So there you go. Okay, so let's try number 12. So number 12 says the absolute value of a plus 2 equals 7/5. So the absolute value piece is isolated. So now we can just apply a plus 2 equals a positive 7/5 or a plus 2 equals a -7/5. And then we're just solving for a, just like we did in the earlier sections of chapter 2. And we're going to actually do both of the same steps to get there. So we're going to subtract 2 from both sides. So a equals let's just do a 7/5 is 1.4. So we're going to subtract 2. So a equals a negative 0.6. Or over here, we're also going to subtract 2. And so it's a negative 7/5 and a negative 2. So that negative 1.4, that's what a 7/5 is, minus 2 gives us a negative 3.4. And like always, you can go to Desmos and put this in, and you will be able to find out where it equals 1.4, and it will show you in Desmos. Okay, so I'm going to show you how I would do this one, because then you can go and check the rest of your problems as well. So in Desmos, if we had the absolute value of a plus 2, and then I wanted to see where does it equal 7/5, I can just put a line at y equals 7/5, and then it will automatically show the intersection. So you can see where it showed at the negative 3.4 that we came up with. And then also there's the other one at negative 0.6. So you put in the left-hand side of your equation as its own equation, y equals absolute value of x plus 2. And then you put in the right-hand side of the equation as its own equation, and it will graph both of those. And then you can see the little gray dots are the intersection points. So this is how you can check your work. Okay, so let's look at number 24. So number 24, our absolute value is isolated. So we can say 3x plus 1 equals 4, or 3x plus 1 equals a negative 4. And so we're going to subtract 1, trying to solve for x. We get 3x equals 3. And then we're going to divide both sides by 3. So x equals 1. We're going to do the same steps over here. So subtracting 1, trying to isolate x, we get 3x equals a negative 5. And then dividing by 3, we get x equals a negative 5/3. So we can always check to be sure that this works. So if you put in 1 for x, you'll get 3 times 1 is 3 plus 1 is 4. If we put in a negative 5/3 for x, the 3's cancel out. We'll get a negative 5 plus 1 is a negative 5. And then when we evaluate the absolute value, I'm sorry, is a negative 4. When we evaluate the absolute value, we get a positive 4. So those are both solutions. Okay. Let's move up to some trickier ones. Again, this is just should be giving you lots of good practice on solving equations in general. So again, we're going to isolate our absolute value by subtracting 4. And the absolute value of a negative 5/3. Well, there we go. We had it again, didn't we? No solution. Because anything that comes out of this absolute value is going to be a positive. It could never equal a negative 1. No solution. Okay, let's try number 36. We're going to isolate the absolute value by subtracting 2. So the absolute value of 4 minus 2/7 x equals 12. And then we're going to say, okay, so 4 minus 2/7 x equals 12, or 4 minus 2/7 x equals a negative 12. Okay. So we have to multiply each term in the equation by 7. So we're going to say 7 times 4 minus 7 times 2/7 x equals 12 times 7. So we'll have 28. These 7's cancel, so minus 2x equals 12 times 7 is 84. And then we're going to subtract 28. we get a minus 2x equals 56. And then we divide by 2. And so x, divide by negative 2. So x equals a negative 28. And then over here, likewise, we're going to multiply each term by 7. So similarly, we get 28 minus 2x equals a negative 84 this time. So notice that a lot of times these look almost identical, but just a negative here and there. So we're going to subtract 28 again. And so this time we get a negative 2x because it's a negative 84 minus 28. We get a negative 112 divided by a negative 2. We get x equals 111 divided by 12. Negative 111 divided by, 2. And negative 111 divided by a negative 2. I'm getting my words mixed up today. X equals 56 for 36. So let's look at the next one. Ooh, the next one looks fun because there's a lot going on inside the absolute value this time. So the absolute value is already isolated, so we can just go ahead and say 5 equals 6 times k minus 2 plus 1, or a negative 5. Oh, let's do that one down here. A negative 5 equals 6 times k minus 2 plus 1. So we're going to distribute the 6 through. So we get 5 equals 6k minus 12 plus 1. We're going to combine our constants. So 5 equals 6k minus 11. You're combining the like terms on each side. And now our variables all on the one side on the right. So I'm going to move my constant to the left by adding 11. And we get 16 equals 6k. And then we're going to divide by 6 to isolate k. And so 16 divided by 6 reduces to 18/3. I mean 8/3. Then over here, we're, like I said, similar steps. We're going to distribute. This time it's just equal to a negative 5. So 6k minus 12 plus 1. And then negative 5 equals 6k minus 11. And then we're going to add 11 to both sides, just like we did before. And we get 6 equals 6k. So we're going to divide by 6. And so k equals 1. These are fun, aren't they? So we have 2 more left, 50 and 58. So 50 is a little bit different because it has absolute values on both sides. And you'll notice in the book on page 171, they give some great examples, so don't worry. That you're just taking, you're going to leave the left-hand side as it is, 3a plus 2, and then you're going to take it equal to the positive of the right-hand side, 2a plus 3, and to the negative, but make sure you put that right-hand side in a parenthesis. Okay, so ours, this is not a 15, so it's 5a plus 2 is equal to 4a plus 7, or 5a plus 2 is equal to a negative, and then in parentheses 4a plus 7. And then we're going back to our strategy from page 110. So we don't have any parentheses or fractions, but we do need to get all the a's to one side and the constants to the other. So I am going to subtract 4a because by now, you know, Mrs. Mean likes my variables on the left. So a plus 2 equals 7. And then we're going to move the constants to the right, to the left, to the left, to the right, to the right. See, now you can sing a song. A equals 5. Okay, now on the right hand side, we do have parentheses, so we have to distribute this negative through first. So we have 5a plus 2 equals a negative 4a minus 7. And now we can move our variables to the left, but we're going to add 4a because it was negative. So we have 9a plus 2 equals a negative 7. Subtracting 2, 9a equals a negative 9. Dividing by 9, a equals a negative 1. So just a little bit extra step here where we're going to take what's in the absolute value by itself, both sides, just as it is. And then the 1 will be the positive of the right-hand side absolute value, and then a negative of the right-hand side. So let's do one more of those. So we're going to take the left-hand side as it is. So 0.0 minus 0.01x equals 0.08 minus 0.02x. And then the other side is 0.07 minus 0.01x equals a negative of the right-hand side, 0.08 minus 0.02x. Okay, so we need to get the x's to the same side. I always move mine to the left. So that means because we are subtracting 0.02x, we're going to add 0.02x. Both sides. So we'll have 0.7, and then I'm getting out the calculator. So we have a negative 0.01 plus 0.02. So we have positive 0.01x right here equals 0.08. And I need to get my constants to the right. So because it's a positive 0.07, we're going to subtract it. So we have 0.01x equals, again, 0.08 minus 0.07. And we have 0.01, 0.01. What in the heck? I bet 0.01. It's just 0.01. So we're going to divide by 0.01, 0.01. And that's cool because x equals 1. Okay, now the right-hand side, we have to distribute through that negative first. So we have 0.07 minus 0.01x equals negative 0.08 plus 0.02x because it was a negative, so it made it a positive. Okay, now we have to move our x's to the left. So because it's now a positive 0.02x, we're going to subtract 0.02x. So we have 0.07. Okay. So we have a negative 0.01 minus 0.02. So we have a negative 0.03. So minus 0.03x equals negative 0.08. And to get our constants to the right, we're going to subtract 0.07. So we have negative 0.03x equals, combine them again, negative 0.08 minus 0.07 is a negative 0.15. Negative 0.15. And then we're going to divide both sides by negative 0.03, negative 0.03. And let's do that in the calculator. So a negative 0.15 divided by negative 0.03 is 5. So x equals 1 and x equals 5 is what we come up with. Okay, catch me back for lesson 2.7. This was 2.6. 2.7 is this more of this. So you're going to get some more practice, but it's just inequalities, which we've already done a couple lessons of. So it's kind of putting a couple different things all together. So I'll see you in just a bit.